city of Hull thrives on its port. Its whole history is interlinked with the sea and has played a part in not only trade but key conflicts like the Civil War. Its 800 years of seafaring history has given it the name of the Maritime City. Its status and prominence earned it early railway status, and timely connections were completed via the Selby and Hull Railway. But as the railway dock was completed in 1846, another scheme was falling by the wayside. The Hull, Sheffield and Midland Direct Railway was being passed through Parliament. It was keen to run a line from Hull to Doncaster. It's not clear why it failed, but a mix of the bubble bursting, or maybe a mix of certain MPs unhappy with the route, was planned may have been a cause. We will never really know, but after failing, the plan was eventually abandoned. That was until 1860. The dust had settled and Parliament was more open to ideas, as long as the finances were stable. The idea of a line from Hull to Doncaster was floated again. However, the North Eastern Railway, a powerhouse in the area, spoke with the promoters and convinced them to withdraw the scheme in favour of its own. The line would go from Hull to Doncaster via Saddlethorpe. It still faced a battle as 3 other schemes were all put forward with the same idea. All 3 were put before Parliament and the NER won out in the initial stages but lost in the House of Lords. The NER was undeterred and had reached an agreement with 2 other railways and agreed running powers, and it was third time lucky as the Act was eventually passed. The North Eastern Railway would build the line and the South Yorkshire Railway would branch from it. The line would also link the Yorkshire and Lancashire existing railway at Goole from Potters Lane Junction. One of the challenges the railway would have to overcome was the River Ouse. The line would cross at Goole. Being relatively flat and with a town nearby to facilitate, it was the easiest crossing. Close to the start of the mouth of the estuary, going east of Goole would mean more cost, but going west would be not much of an option either due to the geography. Goole in particular was concerned. Its port was a major player in exporting coal, and despite its major railway connections, it still relied on its shipping going up and down the Ouse. But this left a problem. Similar to the ones in London, tall ships would need to travel up and down the Ouse, and any form of standard bridge would cut off these ships into the towns. The problem was given to Thomas Elliot Harrison to fix. He had been an engineer in the NER for many years, even before the NEI was amalgamated, and had worked under Hudson on the York, Newcastle and Berwick Railway. When the North Eastern merged, he kept his position, becoming its founding engineer. He was an experienced builder, having built bridges and railways before, but this new bridge was going to be a bit more of a challenge. The low banks on either side meant he couldn't get much height clearance across the river, but a tunnel was out of the question. Although tunnels under rivers had been done, the tunnelling under would be simply too costly and take too many years to complete. What was needed was a bridge that would move. In London around the same time, the Tower Bridge was in its final stages of planning. It was a bascule bridge and used a series of weights to lift the central span, allowing ships to pass under. However, Harrison concluded that a bascule bridge would not work for rail, and there was no real solution that was available with the technology that they had. It was later sold in 1901. By then, tall-masted ships were being scrapped in favour of steam-powered ships, and the need for bascule bridges was lessened. So how did Harrison fix the problem? He designed a bridge consisting of 4 fixed spans, each 116 foot long, and were made from iron girders. Each one was supported from the water by concrete and stone piers. But span 5 was designed to move, not upward, but it was designed to swing out. The swing bridges, as they were called, were perfect for railways, and several existed up and down the country, with the first being designed over the River Severn. The central column contained an hydraulic accumulator. Hydraulic accumulation usually contained either gases or a hydraulic fluid. The hydraulic medium was kept under pressure, and in doing so provides a small reservoir for energy, ideal for moving bridge spans. The bridge would rotate around a central pillar and would use a 3-cylinder hydraulic motor. To charge the hydraulic accumulator, steam engines were used, and there was also a backup steam engine and motor in case of failure. To help make the movement as smooth as possible, 36 rollers were installed on a box girder. At a pinch, the bridge could open its 670-ton span in no less than 50 seconds. The mechanism was controlled by a man called the bridgeman. In the control room, he was provided with an indicator, similar to a clock, and it had 2 hands, one showing the course position and the other showing the fine position. The bridgeman would steer the bridge to its correct alignment, and when the bridge was put back into position, spring-loaded bolts would secure it into place. If the bridgeman needed to move the bridge again, he would simply release the bolt with a lever. For safety, it was decided that self-acting signals would be used. The signals would only show as clear if the blocking bolt and the resting blocks on the swing section were bolted and secure. This meant no false signals could be given. There were still 2 signal boxes on either side of the bridge, but they were closed in 1933 when the colour light signalling was introduced. The bridge was completed in 1868 and opened a year later, and it worked as intended. It had a successful career, although it did see several crashes into the pier, and in 1922 the engine room was damaged in a fire. As with all railways, the NER merged into the Big Four and then into British Railways. BR saw the line as a loss and the span was getting old. It wasn't used as much either, as the number of larger boats needed to get to Selby lessened. British Rail put procedures in to close the line and ultimately remove the bridge. However, the locals and historians decided to step in. Although British Rail lost money every time a ship hit the pillars and repairs were made, it had to comply to keep the bridge running when English Heritage gave it Grade 2 listed status, and it has been touted as one of the finest examples of a swing bridge in the country. To give it context, only 5% of the UK's infrastructure is listed as a Grade 2. Over the years, the iron girders were in urgent need of repair, and the whole system needed much needed modernisation. So a programme was implemented. Network Rail took a more sympathetic view and hired contractor Britcon to carry out the works, including strengthening. The line was closed for 6 weeks while 45,000 rivets were removed and tension control bolts were put in their place. Visually you can't tell, but they added a new dimension of strength which would last for years. The swing bridge still works as perfectly as it did the day it opened, and is regularly open to let ships pass through to Selby. The control room, or signal cabin, is still original, allowing for modern technology, and it remains one of the oldest signal cabins in operation. It still opens for regular traffic and as a part of Goole's heritage. It's a great line, and although it doesn't have a strict operating time, if you are lucky enough to see the bridge in action, it's rather impressive.